Hello. Good morning, ladies and gentlemen. Welcome to this last parallel session of the conference. I hope you are all quite fit after the nice conference dinner last night. I must admit that I'm still missing two of the speakers who are supposed to talk this morning. Fortunately, we do have the first one here. So if anybody is here and who is a speaker, please turn up here. But it doesn't seem to be like this. Okay. So we start as it is, and then we see if they turn up. Otherwise, we have to skip to the end. The last speaker is here as well, so I'm very happy about that. Okay. So our first speaker is Spiros Papageorgiou. Sir? Yeah, okay. It's a bit difficult to pronounce. And he's a senior network engineer at the National Technical University in Athens. And he's there involved in the GRNet and the NTA network management, and is also participating in the GN2 JRA5 activities. And he is now talking about integrating multiple wireless access control schemes at the NTUA, and we are looking forward to a talk. Welcome. Whatever you like.
Well, okay, so I have to see the screen. Good morning, everybody. I hope you had a good time last night, and I also hope you had a good night's sleep. Well, okay, it's going to be fast and painless. I am Spiros Papageorgiou. I'm going to talk about the NTUA's wireless network. NTUA is the National Technical University of Athens. Let's find the presentation. Okay.
Oh, by the way, when I was looking at it, I was told to remind you, please give back your evaluation forms when you go to the plenary session. And you know probably that you will get a little gift when you give everybody a form. That's a gift if you don't give it the evaluation form. So please remember to return. Thank you. Sorry.
Yeah, okay. So, first slide. Well, first a few things about what we have in NTUA. We have a network infrastructure that is switched based. We have layer 2 topology. We only have switches and just on routers. So we are using VLANs to separate users and segment the address space. We also have an LDAP server which contains the user accounts and the user's passwords. We don't have the unencrypted passwords. We just have the encrypted versions, and this means that we can't do CHAP or something like that. We only can do PAP. We also have a free radio server and not radiator, and we're very pleased with the free radios. And we also have a PKI infrastructure that is not currently deployed widely, but it's in the early stages of testing. Okay. When we designed the network, we just wanted to use as much open source software and vendor-independent hardware as we could. So these were our guidelines. Now, we tried to separate the users and make some categorize the users in respect to the user-friendliness of the solution that we would give them. So we thought that the first category should have users that don't want to set up anything, and users that don't want to install any software. Well, the second category should be users that just want to set up something, but not install anything. And the third category should be users that are more experienced and that would, that don't mind to do some setup and also do some software installation. So we gave 3 categories and 3 solutions. The solutions were web-based authentication for the novice users that don't want to do any setup and don't want to do any software installations. Well, most users just want to join the wireless network for a few minutes and just see an email, so they don't want to do any setup or software installation. So we gave them a web-based authentication with Radius backend and all that kind of stuff. We will describe it later. The other users, the second category, that just wanted to do some setup, they didn't mind. We just gave them the IPsec VPN solution with a standard setup, a standard Windows setup of L2TP. The third class of users, we gave them .1x, which we believe that it is the future authentication method for wireless networks. Well, this is our network. We have the switched network, and all the access points are connected to it. We're using trunk connected access points. We're using .1q for the trunk connections. And because the access points are Cisco, we're just using two SSIDs. One SSID is for the web-based authentication and the VPNs, and the other one is for .1x. So when the user at the first time, he doesn't know anything. So when he joins the network, he joins the broadcasted SSID, which is the open one, and any user can associate with it. So you can see on this page that the first page that the user sees is this page that he can see the selections, the choices he has. So he can see that he can type his credentials into these boxes and join the network with the web-based authentication scheme. But he can also read the details of the VPN connection and the .1x solution, so that he can set up his laptop in order to use the other methods. Now, a few things about the web-based scheme. Well, yes, we are using a FreeBSD box, which is, has two interfaces and is used as a gateway to the network. So when the user joins the network, it does a DHCP. The FreeBSD box gives him an address. And the user opens a web browser and goes to some address. Well, because we allow DNS, the user can resolve the IP address of the website. And after that, we intercept the packets and we forward them to the SQUID process. And we're sending them to the Apache server in order to display the page you saw before. The components of this system is the SQUID for redirection. We're also using IP firewall to intercept the packets and send them to the SQUID process. We have an Apache server and DNS server. And we are using IP firewall in order to do MAC and IP authentication, in order to put the access list statement, in order to allow the user to allow the user's traffic to pass by when he authenticates. Of course, because it is a web-based scheme, the user needs to have the web browser open. So when the user logs in, he sees a web page that says, "Don't close this page." Of course, most users close the page, but they shouldn't, because after that, after timeout, the system logs him out. The second solution is the VPN's IPsec solution. We are not using any access server like switch, but we are using the standard L2TP setup that Windows and other platforms, of course, have in order to use the VPNs. It is just an L2TP setup, but what we did for the VPN server, we have the FreeBSD box, and we're using the IPsec kernel functionality of the FreeBSD box in order to have IPsec. We're using certificates for this solution. So we're using a Raccoon for iKey negotiation. And we are also using L2TPD in order to establish the tunnel over the IPsec session. For L2TP, we're not using L2TP to give IP addresses. We're using PPPD, which has radius support. There is a patch for radius support. And PPD combined with the radius gets an IP address from the radius as an attribute. The radius server has a DHCP functionality, DHCP-like functionality, and gives the address to the user with PPPD. As you can see in the slide, we also have a Sun Crypto Accelerator card. It's a VPN accelerator that does not have drivers for FreeBSD yet. The card works because we have patched, we have made some sort of driver. It has a standard chipset. But to tell you the truth, the functionality of 3DES acceleration doesn't work yet, but we can do public key, secret key negotiations very fast. And I believe that in really soon we would be able to do the IPsec acceleration, the main core. The third solution is the .1x, the well-known solution. The clients, the users may use certificates, and they also may use apt TLS. Just because I told you that we don't have our PKI infrastructure is not really deployed yet, it's in a test phase, not so many users have client certificates. So most users use secure W2 that from Alpharis Corporation that is funded by Surfnet for TTLS authentication based on PAP. Because we have the encrypted passwords, PAP is the only protocol that we can use. With .1x, as you know, the user may take a dynamic keys, and access points and users may change these dynamic keys all the time in order to establish a secure web connection. This is a slide about .1x and how it works. The user logs in. The access point doesn't really allow him any traffic except app traffic. So the user establishes through a secure W2 a TLS tunnel with a free radius server, and he passes his credentials over this tunnel. And when the user authenticates successfully, the free radius passes a few attributes and tells the access point to open the doors for internet for it. Also, the free radius passes the attribute of VLAN, so each user may connect to its home VLAN. And this is a very good selling point for .1x. Well, about some discussion about limitations and conclusions at the same time. Well, we have the problem with web-based authentication, because when the user logs in, it connects to a web page, it fires up a web browser and connects to some internet site. He sees a web page. The web page, the Wi-Fi login web page. But when he tries to access this page, his home page, for a second time, he sees again this login web page. Why? Because the browser has cached the previous page. This is a problem. Of course, if the user is not blonde, he may do a refresh. But even if he does a refresh, Internet Explorer again shows the same page, the Wi-Fi login page. This is not nice. So the user has to do a control refresh when we're talking about Internet Explorer in order to force a real refresh. Of course, there's the other problem that users really keep closing the web page that should be open. Of course, that's their problem. Okay. And the other point is that most handheld devices is that they can't have two web pages open at the same time. Well, with VPNs, they are not very fashioned because, as I told you, we don't. Not many users have certificates, client certificates, so they can't really log in. But here I have a proposal or some sort, and I hope that I could show it to you in this presentation, but we didn't have the time. When the user connects at the first web page with open authentication, he sees the login page. Well, he can click on this web page and redirect him to go to some HTTPS web page, some secure web page. Well, with this web page, he can download an ActiveX controller or something automatically. He just has to click yes, and if not only an ActiveX, ActiveX is only for Windows, perhaps some executable, because in this way we can use not certificates, we can use a cert key password for IPsec, and there are tools to set up a VPN connection automatically. So imagine that a user just visits a web page, the Wi-Fi server generates a pre-shared key, builds the ActiveX control, and gives it to the user. The ActiveX control sets up the VPN connection, and the user just has to click on the VPN connection to connect. It's a few clicks away from a VPN setup. The user doesn't have to do anything, and you don't need certificates. It's a point to discuss. Okay, about .1x, we think it's the future authentication method. Most drivers nowadays support .1x, and we think this is the way to go in the long term. Of course, not many users use it. For example, in NTVA, just electrical engineers use .1x because these are the ones that are more familiar with their laptops, and they don't have problem to install some software and do some setup. The other users, mechanical engineers, the other architects, they just use plain web-based authentication schemes. Well, that's about all. Thank you very much, and I would like to hear your questions.
Yes, thank you, Spirit. And yes, please.
The question concerns to the web-based authentication mechanism. So if I correctly understood, prior to the authentication of the user, all the traffic is created by the host is blocked, for instance, at the first router in the middle of the wireless network and the rest of the network. So when you block that traffic, do you do this by filtering on the MAC address until that MAC address is authorized by the login, or do you do it by, for instance, filtering on the IP address which is currently assigned to that user, so before the correct login? The first question, which one?
Yeah, okay. As you can see, we allow some traffic to pass by. We don't block all traffic. We allow DNS, DHCP, ARP, and these main protocols that are needed in order for the user to come up and have IP connectivity. So the user gets an IP address because we allow DHCP. But other than that, the firewall says that not any traffic other than DHCP and DNS is allowed in. When the user authenticates, because of the web redirection, we put an ACL in the IP firewall statement that says MAC and IP. It's a combination of MAC and IP in order to be more secure.
So you use the dynamic firewall on
Yep.
the end of the system. The second question is, as you authorize the access to an IP address, how do you avoid that prior to authentication, users do not consume your bandwidth, wireless bandwidth or your network between each other? So imagine two users being on the Wi-Fi network, just getting that IP, getting that local connectivity. Maybe they don't care about external services at the moment, and they just use it as, let's say, a big switch for them. So How do you avoid, for instance, this kind of...
Yeah, because there is a feature in the Cisco access points that don't allow any local traffic, and they need to send it over the Ethernet. The feature says that any wireless user should pass from the Ethernet, not the wired Ethernet. Okay.
So you avoid that?
Okay, we don't care about that, to tell you the truth, but there is a feature that does that. Okay.
Okay. Any other questions? Okay, yes, please.
Using free radios for 802.1x, you have problems because the 802.1x support is not full in current free radios. The CBS stuff.
Okay. So, good morning everybody. I'm hoping that you are fresh after the last evening's dinner. So I will be talking about streaming infrastructure incarnate and our way of using it to support e-learning. So this presentation will not address e-learning as it is. So this will be some technical issues regarding streaming and how it can be used for distance learning. So the presentation will contain overview of the current streaming infrastructure, that is what is contained in it. Goals we wanted to accomplish with the solutions we are developing, what we have developed, and features and bugs of the solutions, screenshots of that applications, and Q&A. If there will be time, I can demonstrate both solutions. I don't know how much it will take for me to demonstrate. So, let's start. So, our streaming infrastructure has been developed over the years. We have started developing it back to 1995, 1997. As you can see, it has three main elements. We have MOD system, media on demand system. We have streaming servers and portable encoding sets, that is computers with the cards that are used for encoding and other computers that are doing post-processing of materials. So with MOD system, we have proprietary metadata scheme. More of that scheme you can find on our server. It has been developed with the task force stream sometime in 2002, I believe, no, 2001, by a colleague of mine, Zvonimir Zelenika. Some of you know for him. So you can find that document describing our scheme on our web, and I believe maybe somewhere on Terena web, I don't know. As for the streaming service, we have all three of the main services that you can find on the market nowadays. We have been using Windows Media as our main infrastructure for the past few years, but now we are switching to the Linux in our company, so we have bought Helix full version. So we'll be supporting both real and Windows Media as for the time being. We are preferably using Windows Media, but we will switch both to real and Windows Media soon enough. We have also Darwin, but we are not using it at the moment in some greater extent. As I have said, we have portable encoding sets that are mainly used for the live coverage of the conferences and other events that need to be covered for the streaming audience. I don't have much to say about the sets. It's usual Windows Media encoder on the machine and real producer, so it's nothing complicated for the time being. So as you probably know, it's not easy to gain a lot of audience for the streaming content, and that's why we have thought of a way to attract some other clients that could be using our infrastructure in other manner. So we have decided to try to develop simple e-learning tool with these features that you can see on the slide. So main thing with this system that we wanted to develop was that it should be simple to use, plug and play, as to say. So we have some tools. We have learning management systems in the company that are quite complicated to use. So the idea was to have something that will help lecturer create some content for its students that will be easy to use and easy to create. So the lectures should contain all the elements that are needed for the lecture: audio, video, slides, and notes that the lecturer is writing, and anything other that lecturer would like to include, examples, online tests, and stuff like that. The other thing that we wanted to include within it is interactive whiteboard. So for these notes that we wanted to capture, the easiest way to do it was interactive whiteboard that you can write on. You can write on the whiteboard. So that was an idea how to capture the notes quite easily. Also, we didn't want to have our presenters have to use only PowerPoint. So we wanted to have any application that lecturer wants to use while he is presenting, that we will be able to capture it. Of course, the streaming infrastructure is fully used when the broadcast of that lecture is instantaneous as the lecture is taking place. So that was one of idea within it. Advanced navigation and synchronization of the materials is something that has to be done in order to get a fully functional solution. Of course, there is support for different players, browsers, OSs, and stuff. So, what we have accomplished is two solutions. The simple one is the one that you may have seen on the Terena last year. That's the core of it. It is used for that. So it's based on integration of PowerPoint presentation with a Windows Media encoder. So with this solution, we have bound ourselves with only one architecture. So we are only using Windows Media with this solution. As for programming part of solution, is based on JavaScript and Visual Basic macro that you can find in PowerPoint. So it's not easy. It's easy to program. You don't have to be a programmer to work with this. I'm not one, so. We have managed to synchronize audio and video with slides. The broadcast is taking place, is instantaneous as the event is taking place, and archive is pretty soon available after the lecture. If there is no post-processing, if you start the encoder and all the computers while the presentation is starting, you can have an archive immediately after the session. You only have to stop the encoder and to put the file on the server. So it's pretty much immediately after the lecture. If that is the case, you don't have any post-processing. You just put a file on the server. You have slides on a server, so everything is ready within a minute or two. As you have seen, we have customized controls and look and feel of the solution. I will show you later on. I will show you the screenshot of the solution, and I suppose that we will have time to show the solution live. But problem with this solution is that lecturer has to use PowerPoint in order to get the solution running. So we didn't want to have that, and that's why we have started developing a solution that will address other features that we wanted to accomplish. So we have solution 2 that is not as simple as the solution 1. I don't have names for the solution right now, so I'm using solution 1 and solution 2. I don't know how to name them. So the other solution is integration of presentation computer desktop with the audio, video, HTML, and other stuff that will be included in the lecture. So this solution is not bounded with the PowerPoint. So you can present in PDF or PowerPoint or any other application that is on the desktop. Seek throughout the lecture can be made by slide titles. So you can skip from one part of the lecture to another by the title of the segment of the lecture. With solution 1, you didn't have that possibility. You could only skip to a certain part of the lecture by timestamp. You couldn't use titles within the lecture. So this is advanced. Every element of the web page can be synchronized with the stream. So that means that you can have both examples and surveys and synchronized within the stream. So you can have question for each segment of the lecture that is synchronized with that slide. So you can click on the question and you will have a question related to the current slide. This solution has been developed with the interactive whiteboard. So the lecturer was writing to the board, and everything that he had been written has been recorded in a stream. So everything can be seen. Downside of this solution is significant post-processing that has to be used in order to get it to work. So that's one of the reasons that it's not possible to have broadcast as the event is taking place. You have to do a post-processing, so you can't have stream of the presentation in the same time. Good side of the post-processing is that you can include everything that you want within the lecture. It's also very simple. Everything is written in JavaScript, so it's not easy to create it. Results and impressions. Some of you have seen the solution, the base of the solution number 1 for the last year conference. We had very good feedback on that solution. So this is proven in practice that is good. Both solutions we have developed are at the moment working with only Windows Media technology, but we have started to look for solution that can be made with real technology. With the solution number 2, there are problems with synchronization, as the solution number 2 is based on 2 streams that are simultaneously flowing from the server, so there can be a problem with the synchronization. We have managed to avoid these problems with enough bandwidth. So if you have good bandwidth, you shouldn't have problems with it. So that's one of the downsides. That is that if you have slower access speed, you can't use it at all. So with the modem, you can't use the solution number 2. Minimum of 2 computers has to be used for processing. So you have one computer that is desktop that you are capturing, and the other one that is processing audio and video. I guess that you can use only one, but it's safer to use 2 for the time being. And of course, it's not plug and play. The pilot, while we are testing solution number 2, we have used 2 or 3 people to get it work. Now, when we have the technology, I suppose that one man could do it all, but it's not the solutions that you can use if you are only lecturing, giving lecture. So I will show you the screenshots. This is the solution number 1 that has been used for the last year's conference. We have 3 or 4 main elements of the layout. You have video and audio on the left side. On the right side, you have slides that are changing when the presenter is changing them simultaneously. Upper, you have schedule, so you can pick the solution. You can pick the lecture that you want to see if the lecture is in archive. If not, if the event is live, you will see the current event. So the current event will be in the middle of this window. Upper, you can search the archive, and archive can be searchable with any word that is within biography or the abstract that you can find below. So we have developed customized controls for the player on the left. So you can turn the sound on and off, and you can use all controls while you are watching archive stream. But while you are watching live stream, you can only stop it and make it and play it. Solution number 2 is a little more complicated. You have 3 elements also. You have audio and video on the right. On the left, you have presentation desktop, the desktop of the presentation computer. So the lecturer can write on this desktop. As you can see, he was writing something, and everything that he writes gets recorded. You have search engine within the lecture, so you can pick whatever slide you want from that lecture, and you have additional window with examples and tasks that are related to that slide. Lower down, you can find complete tests for the whole lecture, questions, materials, and all other things that lecturer finds that will be useful for that lecture. So basically that's it. I can show you live some of these if you want. If not, I will take questions. I don't want to bother you. I know that you're tired from the last evening.
Okay, first of all, thank you. Is there a question to the audience?
see it live.
Yeah, okay. Then
Okay, I think we have a question.
Oh, sorry.
Do you have a look to VideoLAN project about video streaming?
I'm sorry, once again.
Do you have a look to VideoLAN project for streaming?
I think we didn't.
Because the main advantage of this project is a universal platform. You have now, for instance, you have only Microsoft.
Yes, that is, but with the solution one, we have bounded with Microsoft because of the Windows Media Encoder and the PowerPoint, because they're talking to each other. So we have to use Windows Media for the solution one at the moment because of the PowerPoint. It's the easiest way to do it. As for the solution two, yes, we can look at any other infrastructure, any other platform. So I will show you. Hopefully it will work. So I was saying that this solution has been developed for the Windows Media Player 9 series. We have thought about, and it supports basically all other Windows Media players, but it has been written for the Windows Media 9. And we haven't changed it much after that. So that's why we have this error window. Yes?
Are the templates and code that you use behind that available, or is everything in Croatic and we will not be able to use it?
Everything is available. So, but this tool that you are interested in is these two windows down there. It's pretty much simple, and for the upper part with database behind it, that was one solution that has been customized for only this use, for only this. So you can use it, but it's not important for you, I think, at the time being. So this part lower down, yes, you can get it without any problems. So you can see the presentation on the right and the video on the left, because here is. Here I don't have Windows Media 9, I suppose. This is Windows Media 8. So I have this smaller window left, because there are differences. There are great differences between Windows Media 9 and the lower version of the player. So I suppose these commands are working. Yes, they are. So you can pause the presentation. Start it again. Sound on, sound off, and this slider here shows part of the presentation that you are watching. So if you click here, you will skip. This is skip or search within the lecture. So it's maybe not graphically too intuitive, but that is search. So this is the solution number 1. Any questions related to it? No. Okay. And this is solution number 2. So you have slides on the left, that is computer desktop on the left, and player on the right. So you can search throughout the lecture. And you have materials related to that slide, and tasks also. So, I suppose he will write somewhere, so you can see it while he's writing. So the task here is different than the task we have seen before. So this is related to that slide particularly. And now he is writing. So he's circling something a lot. So here we have tests related to the lecture. And you can print out slides and stuff like that. So you can use whatever you want to have the complete lecture. So any questions related to this? No? Thank you.
Okay, thank you. Now I would like to give Martin Continent another chance if he has turned up by now. But it doesn't look like it. Okay, so we will not have this presentation then. Oh. Thank you. As this is a recent result session here, so we really have very different topics in this session. So the next one will be very much far away from the swimming, and will be given by Dimitris Alexopoulos, who is a senior software engineer and also a PhD candidate at the National Technical University of Essex. And you are talking about cost-effective IP networking. So, quite relevant. Yes.
Hello all. Indeed, it's a quite different topic from the previous one. Nevertheless, I'm going to talk to you about cost-effective IP network management based on XML authoring. It's an undergoing work done by myself and Dr. John Soldatos, who is from the Athens Information Technology. Now, first, an outline of what we're going to talk about. We'll start from the legacy systems in IP network management and a short overview of them. We'll refer to XML technologies and the way that they can be utilized for XML-based management. And therefore, we propose an architecture for such an XML-based, let's say, network management scheme. On this presentation, we will focus on the element level network management, as long as we have not yet implemented the network level management, the proof of concept prototype. So we'll refer as well to implementation, a prototype, a proof of concept implementation of our architecture, and we'll refer to some performance issues that of course are really important for such a topic as network management. And finally, we will close with some conclusions and future work to be done. First of all, nowadays the main protocol used for network management is the simple network management protocol, which, as its name implies, is of course simple, and in addition, it has a very large installed base. On the contrary, when it comes to complex operation or configuration management or some more tricky tasks with network management, it seems not to be the most effective solution, or maybe it's a little bit difficult to use it. So, in addition, when we refer to terms like openness or flexibility, SNMP is a little bit sort of providing terms like that. So, what we propose as a solution is to leverage the emerging XML technologies. Now, regarding the XML technologies, first of all, they are standardized data structures. They are open and flexible, and a lot of third-party application programming interfaces are provided to manipulate data and so on, and maybe validate them using, as we see on the later bullet, using DTDs or XML schemas. Of course, there are a lot of W3C technologies emerging, such as XPath or some technologies around XML. And as long as the XML has high-level semantics, it cuts development and deployment cycle to only a fraction of the typical network management development and deployment cycle. Of course, there are some issues we have to deal with. First of all, security. We cannot talk about network management and not mention security. It's the first thing that we should have in mind. In addition, data overhead imposed by the use of XML, as long as we have the standardized structure of XML, is an issue that we should deal with. And of course, the performance. A lot of stress tests need to be taken to see whether XML-based management is effective and what is its shortcomings, maybe. Now, the target of our proposed management architecture is to be structured in multiple tiers. So, first of all, we could refer to the element level management, go one level up and maybe assembly some operations and some functions, some management functions from the element level, and provide network level management. And on the upper level, from the network administrator view, we could provide as well service level management. As I pre-mentioned, our target is to provide for service use, for service reuse, and service composition to provide upper level management functions. One other feature that we intend to provide is flexibility from the extensive and extended use of XML. And of course, we intend to be aligned with the guidelines of distributed programming, let's say, or something like that, to provide decentralized network management with this architecture. Why we believe this architecture is cost effective? As I pre-mentioned, its development and deployment cycle is rapid. In addition, it's simple and self-describing to develop applications, as it's simple XML authoring. And of course, this can be assisted by the use of a lot of XML technologies. Now, a few words about the overall architecture. We can see here the lower level actual nodes, which for an example are 2 routers and an ATM switch that run the lower level part of the architecture, the element management level engine, as is mentioned here, and which is invoked from a client in general, but in this purpose, for the general for the general example, it's invoked from the upper level, which is a network management node, and it runs the network management level engine. As we can see, all interactions are done with XML messages, both for the NML layer and the EML layer. Now, about the element level management that we're going to focus a little bit in this presentation. It can assist XML configuration of the network element. XML authoring will help creating functions and applications for XML for the configuration of the actual node. As a part of this architecture, XML messages are used for the exchange of data. And of course, we provide for integration with the installed base of SNMP-enabled devices, as long as it's a huge installed base. And we achieve that by using an XML to SNMP gateway, which takes XML messages and transforms them accordingly to simple SNMP commands. And of course, there's a possible integration with other protocols, such as LDAP or COPS, for assisting the tasks of network management. This is the architecture, the specific architecture for the element level management. We can see here multiple network elements from multiple vendors, starting from the down and continuing to top. This is the XML SNMP gateway, from where there is the integration with SNMP-enabled devices. The XML messages pass to this gateway and are processed by the devices. And of course, this is the core module, the XML management engine, which manipulates all the requests to the framework, to the prototype implementation, from the client up here to the nodes. A key component of the framework is the initialization XML documents, where all management applications are described. In other words, the network administrator authors this XML document and writes down the available applications that are comprised of simple operations, of simple, let's say, SNMP operations at this level. This document is part of the management engine and is invoked with this message, and the reply comes back as an XML message as well. Now, as I mentioned, the core is the XML engine. The application development is done through XML authoring and mapping to legacy SNMP-enabled systems to the XML SNMP gateway. Now, a few words about the implementation. The client bases its communication to XML messages or XML RPC invocations. This allows for distributed management, first of all, and the use of XML and HTTP and an additional HTTP interface provided allows for simple interaction with the system. Of course, we could say that we could use some of the emerging security initiatives for XML and HTTP, or the existing ones for HTTP, but of course we should investigate this a lot further. The XML engine is written in the Java programming language, and of course utilizes all object-oriented programming techniques. Now, the two things we had in mind when developing this prototype instantiation was performance and security. For the time being, only performance, only some tests regarding performance have been undertaken, and security is a great part of our future work. Now, the initialization XML document is, as I pre-mentioned, the key component of the application of the framework, as long as it contains all information about the network management applications, and of course, as long as we intend to be vendor independent, let's say, we provide for some module inside the management engine, which is called the vendor adapter, and retrieves information from the initialization document to map abstract parameters to specific vendor-dependent OIDs or parameter names. And this is finally passed to the node, to the network element through the gateway. Now, about performance. We had two possible integration with SNMP, one through the XML SNMP gateway, and one through pure Java to SNMP communication. So we tested both interfaces, and we also tested, of course, our framework, our prototype instantiation, utilizing only the XML to SNMP gateway. The main idea from our performance test is that Java to SNMP communication is a lot faster than XML to SNMP communication, and that is due to some expensive XML processing in the gateway, where messages, where we are at very low level, and messages are processed to be actually passed to SNMP. But utilizing this XML to SNMP gateway, the prototype's overhead was really small. It was less than 5% of the overall time, and is due to a feature. Let's go back here, where the initialization document is not parsed each time. It's parsed once and it's cached in the memory for performance issues. So now about some, let's say, conclusions. Of course, not conclusions in the first meaning of the word, as long as we have a lot of future work to do. We saw it was easy and flexible to develop and deploy some application, let's say a batch of 5 SNMP getters and 2 setters. It was quite easy to develop an application comprising of such simple SNMP operations. In addition, our prototype allowed for decentralized network management, as long as it was not necessary to run it on the node. So we could use it from somewhere else in the LAN, somewhere in general. We target, and we have some work on this, to be system interoperable. And of course, we need to investigate further security and performance issues. Now, about the prototype implementation, what we want to continue with is to develop the network layer, the network management layer, which utilizes the beneath element management layer, and go on with the service level management, where some, let's say, value-added services are added there. And of course, we would like to deliver this application, this prototype, give an interface as a web service, which seems to be the trend in the internet nowadays. So I would like to thank you for attending my presentation, and any of your questions will be welcomed.
Okay, are there any questions? Yes, please.
Two small questions. The first one is related to the security. As you told us, you will investigate the security a little bit further. So do you plan to use or to, let's say, investigate the W3C standards, which are the X sign and X encrypt?
Yes.
You already know them. Because there are lots of free APIs already doing those two technologies available on the net.
Yes, yes. I have done some search about this. I've come up with those tools you mentioned now, but unfortunately we did not have the time to implement incorporate, let's say, their features to our prototyping instantiation. Yes.
They work very well. The second one is related to, here you are talking about a kind of a gateway from XML to SNMP.
Yes.
I don't know if you have heard, I discovered it a few days ago, Juniper has an XML interface to configure their router next to the traditional SNMP one.
Yes.
So, did you try or do you plan maybe to test, to not only making a gateway, but
Yes. I've heard about Juniper's XML, providing XML interface to their products, and I would like to test it. But first of all, we plan to be as vendor independent as possible. So it would be a very nice test for the proof of concept that it could be integrated with the Juniper interface.
maybe we have to weigh that if for one they kind of proprietary solution, but I do not know if the WDC is targeting also this objective, and if they do so, then there will be a real opportunity to do so because it will not be vendor specific.
Yes, and it will be much faster as long as it won't be needed to have a gateway, which is really performance. It's a real performance overhead. Yes, please.
Haven't you looked for another system like this? Haven't you checked it on the internet? I'm talking. I am asking because there is almost the same project in the Czech Republic, which is a part of the liberal generic router project. The name is Netopir, and I think that that project has its own interface to Juniper's interface or the CLI of Cisco and some generic interfaces. So, or it is some kind of special thing.
No, to be honest, I've not come up with this project, and I would be glad if you give me some links to that to see that. Yes. Yes, please.
Does exist application that use this XML?
No. If I understand correctly, you ask me if it's deployed somewhere to manage an actual network. Yes. The XML interface is standardized and validated through DTD. So the structure of the XML messages is documented, let's say, in this DTD. If maybe I did not understand your question well.
But this DTD is your data structure, but
You mean if there's a
application that
no.
this structure and can use this?
No, I can guess what you're asking. No, there is no such standardization procedure for the specific interface, XML to SNMP. The?
Is open your works? Your work,
Yes, it's open. Yeah, I do not have a link here, but I can give you the link to the website of the framework and the architecture, the overall architecture. Yes.
There's another question, yeah?
Last short question. In your development, so you probably have developed a few schemas on your side, like proprietary. Do you plan to, maybe when they will be mature enough, to suggest them to the W3C to maybe start an official one so that everybody will be really, everybody will say ameliorate it, or do you want just to keep for the Google?
Okay. Knowledge, I think knowledge is not something to keep it private. So, of course, it's too early to talk about something like that. I can not even imagine doing such a thing without investigating security. So, the first priority is security and performance, of course, and afterwards we can think of things like that.
Okay, any more questions? This does not seem to be the case. So, as we missed one of our speakers, we can also close the session. And I would like to thank you and the speakers again for the interesting. And as we have stopped so early, you have enough time to fill in your evaluation forms and give them back at the end.